Fantastic.
All right. Thank you.
Right. Good morning, everyone. My name is Ann Vigut, and I am with Engineering Tomorrow. I am a Midwest coordinator, so I kind of cover your area of the country. I want to welcome you to your Wrap Up Bridges Lab. Leading the lab today, we have an engineer coming to you, Joanna Caudle. She's one of our active participants in Engineering Tomorrow. And along with her, Morgan Douglas. Morgan is a college student. She's we would call our college engineering mentor. So she'll lend that perspective. And she is a seasoned veteran with Engineering Tomorrow as well. So you are in capable hands. I'm going to turn it over to Joanna and Morgan. They're all yours.
Good morning, everybody. I know it's early for you all there, but we're really excited to be with you. Morgan and I are very excited to be with you and see some of your designs and talk to you a little bit more about engineering and answer any questions you have. We really want to make this as useful a time for you as possible, so please do uh, engage with us, ask us questions. There's a lot of experience between Morgan and I about engineering, about college, about professional expectations, all of those kinds of things. And we'd love to have a conversation with you this morning. And we'd also love to see those amazing bridges you built. I hope you've been having a fun time with that. I'm going to quickly share my screen and we'll introduce ourselves a little more in a little more depth. So I hope I got this right. The Pickerington Central Tigers. Go Tigers this morning. Um, and let me start by just welcoming you all. What we hope to do today is we hope to see some of your bridges, share some of our experience, and hear from you what your questions are, what you're wondering about. So without further ado, let me introduce Morgan.
All right. Hi, everyone. My name is Morgan Douglas. I am a civil engineering student at Virginia Tech. I'm in my last year of undergraduate studies, but civil engineering is pretty broad, so it actually does touch on structural engineering, which is what you all did when you designed your bridge. But I'm a little bit more focused in on the other aspects of civil engineering. So I'm interested in sustainable land development. So that's designing new neighborhoods, new shopping centers. Sustainably. So making sure that everything meets the codes and also everything is LEED certified or Envision certified um, going forward. I'm also interested in stormwater management. So when there's a big rainstorm, making sure that the water goes into the correct spots. So drains off into the correct curb inlets. And like storm drains on the side of the road going to the stormwater pond, and also water resources engineering. So making sure that everybody has access to clean water.
That's great. I love all those topics, and I have a announcement to make about that. Something that Engineering Tomorrow is we're starting to partner. It's just in the very early stages right now, but we're starting to partner with the organization Engineers Without Borders, which is all about trying to find it's really humanitarian and sustainability engineering and trying to find better ways to support communities that don't have access to some of these key resources like clean water, adequate sanitation. And so I'm excited. I think you'll be seeing a little bit more of that in our challenges as time moves forward. So I hope that's something you'll find interesting. Um, my name, again, as I said, is Joanna Caudle, and I am a mechanical engineer by training. And I worked for a big construction company, a global construction company called Bechtel, mainly in the power generation sector. But Bechtel is um, a big company, a global company, as I mentioned, that has built major projects around the world. They just finished up the Riyadh metro system. They helped to build the Elizabeth line in London, the Lizzie line. They helped to build the Channel Tunnel, the tunnel that goes between England and France. They built the Hoover Dam. So if there's a big project that is quite challenging and complex and involves some risk, Bechtel is likely to be in the mix at some point. So I'm a proud Bechtel employee, was a proud and Bechtel employee. My husband works there, and actually, my father worked there. That's who originally kind of got me into the idea of engineering in the beginning. And I think what really attracted me early on to engineering was um, the way that my father got to go. We moved around a lot when I was growing up from construction project to construction project. And I love the way that I love the way that we got to live in different places. So I started my high school in Ann Arbor, Michigan. Let's go blue. I know that's taboo to say that in Ohio, but I'm just putting it out there to make sure you're all awake. I'm not sure you are. And and anyway, I started in Michigan, but I finished up in Mexico City in Mexico. So I knew that I liked that idea, that opportunity to travel quite a bit. And that was one of the reasons, in addition to liking things like math and science and art and a number of things, I thought engineering might be a career for me. So I worked in the power generation sector of the company, as I mentioned, and I worked on as a mechanical engineer on nuclear plants, um, uh, fossil-fired plants, etc. And I thought I'd just spend a few minutes talking about a couple of my first jobs. Um, so I always really liked thermodynamics when I was studying that in college. And I liked understanding how to improve the performance of things. And so I centered my focus in mechanical engineering on that kind of on those kinds of topics. And you're going to hear, mechanical engineering is such a broad field. You heard from Morgan, civil engineering is such a broad field that you do tend to start to pick a focus where you want to study. And I know Morgan has really looked into sustainable development and things like that. But my first job I was offered out of school was a thermal test engineer for a space company, a space contractor out in California. My parents lived out in California after I graduated from high school, so that all worked out. And I loved space. I loved the idea that we still don't know so much about space. And so I was excited to take this job. The job involved testing satellites to make sure that they could withstand the conditions of space. So what you're seeing in that picture is a satellite inside a vacuum chamber without the lid on. When the lid goes on, we pull the vacuum in the chamber, so there's essentially zero pressure, which is the conditions of space. And then we cycle the temperature to really, really hot temperatures and really, really cold temperatures, depending, which would model how the satellite would experience facing the sun and being away from the sun. It all sounded really cool when I was taking the job as a graduating senior from college. But what I found was I didn't get to know too much about the satellite. I didn't get to know too much about other aspects of the design of the device. I only got to make sure that it was performing as it was supposed to perform, that it would withstand the conditions of space. And I found that I really wanted to know more, but in order to have that, I had to stay there quite a bit longer and earn a top secret clearance. So I started to look for other jobs, and that's where I went and wondered what Bechtel was doing. And I was able to get a job in Miami, in Florida, working with Bechtel. And there I joined Bechtel and I was working at a satellite office for the company. And the main role of the office was to support power development in Florida and also to maintain some of their existing plants. And so, as a new engineer in the company, I was charged with working on some of the maintenance issues of the Turkey Point nuclear plant. And so I'm thinking you're wondering, well, like testing space satellites sounds really exciting. Maintaining a nuclear power plant doesn't sound quite so exciting. Why did you take that job? And part of it was for life decisions, but part of it was to be able to see the bigger picture, which I realized was something I really wanted to be able to do. And so while this job was involving the maintenance of a power plant, by working on different projects for different systems of that power plant, I got to know how that whole power plant worked. I got to know how it performed. I got to help improve the performance of the power plant. I got to work on things to make the power plant more environmentally friendly. This plant is right on Biscayne Bay. And learning about all of those systems in that power plant helped me to understand how the systems in every power plant work, every conventional um, power plant works. And so I encourage you to think about right now while you're in high school, the things that you love doing best. Do you love working in teams? Do you like tinkering with things? Do you like building things? Do you like writing and researching? Think about those things that feel like no work at all when you're having to do them. Those are the things you should try to look for in your job. We all spend a lot of time at our jobs in our lifetimes, and so you want to make sure you're doing things that you enjoy. And so that is something that I learned luckily early on in my career. Something else, I'll just flash back to my initial slide. Um, you can see that I'm also an educator. So I was fortunate to have two careers. I spent the first half of my career as a mechanical engineer in the power business. And then I got to spend the second half of my career as an educator, teaching physics and engineering in a high school in the suburbs of DC, which is where I live, Washington, DC. And I've been able to kind of hopefully uh, I've really enjoyed working with students, and I've really enjoyed my time just the last few years working with Engineering Tomorrow to hopefully bring a little more engineering and inspire you to think more about engineering. And one final thing I'll say, and then I promise I'll talk about bridges, but getting back, one thing for Bechtel is if you're thinking, I don't know if I want engineering, there are so many jobs at these big global companies that I think would be very interesting to you. And even if you're thinking a four-year college is not for me at this time, something that's really, really in demand in the country as a whole are technical trades. And I know Bechtel, for one, is really on, they're having sort of a campaign, a global campaign and a national campaign to try to really show the fun and the need for construction trades, welders, pipe fitters, etc. So if you're into building things and you want to work on really complex projects, that's another area that's really much in demand today. So let me shift gears now, and perhaps have you had a chance to build some bridges? I
Yes,
was wondering what your favorite bridge might have been, and I wonder if it inspired you at all as you were looking at your bridges and working as a team. Maybe I'll stop sharing, and we can hear from you about what you how this went and what you thought. What inspired you about the bridges, the bridge build?
we've completed our bridge build yesterday with the final testing. So pretty much everyone has built a bridge and tested it. So what was your favorite part, guys and girls? What was your favorite part about the bridge building?
Building.
Yeah,
What about the building?
We worked as a team. So, yeah.
I love that answer. That's so great, and to me, it's one of the best things about engineering. What do you think, Morgan? How have you been able to work as a team in your college time?
Yeah, there are many opportunities in college that you get to work as a team. So the group projects don't stop once you get to college. I know back in high school, I really did not like group projects, but once you get to college, everybody wants to be there. Everybody wants to do well on a group project, group exam. So you get to work as a team throughout college. And then also once you get into the real world, everybody also works as a team there. I know that this summer I worked, I had an internship and I worked with a group of, I think, about 7, and we balanced out 155 ongoing jobs. So we all kind of got to work together. We all QC'd, that's quality checked each other's work. So that's really important to learn in high school how you operate in a team, and then also how to balance out the work between team members as well.
Rachel, you had your hand raised. What was the thing about the bridges you liked? Could you hear what she said?
No, could you repeat that?
So she said she liked how she was able to build it themselves and they could see, say again, you could see. So how there were some differences and how they can make it their own. Other things about bridge building? What's something else you enjoyed about it?
That creative aspect, I hope you see that that's something that's needed in engineering, the creative thinking. Did you find that when you were working with a team that everybody's ideas were heard? Sometimes did everybody have a chance to contribute some idea to the design?
Yeah.
How many people bridges support more weight than they thought it would?
How much weight were the bridges able to hold?
How much weight did you hold?
I think it was 75 grams.
75 grams or
Wow.
7,500 grams?
One of them.
One of those. One of those is slightly different. Was it a lot of weight or a little? It's 7,500 grams.
Hmm.
What were some of the other numbers?
That's fantastic. Well done.
14,000.
14,000 grams was another group.
Whoa.
What else?
What did you use for weights, Mr. McChesney? What was the testing system?
Generally we hung 1 kilogram masses or 500 gram masses or 200 gram masses and just kept hooking more and more on there.
Yeah. Did you put them all in a bag, or did you
We did some with the bag. The problem with the bag, like the Kroger bag, was it started swaying a little bit as you added the masses, so that caused a little bit of an issue. So after a while, we just straight hung the masses on the hook you provided with us, and then hooked them onto each other. It made for a much more impressive look of having 17 or so different masses hanging off the bridge.
yeah, I bet.
What was the most common design that was used?
What was the most common design you use?
Those triangles.
Triangles?
Yeah.
Yeah, I see a lot of truss bridges when we do this lab with engineering tomorrow. But in real life you can see why do you choose the triangle shape as the most common one?
Why did you choose triangles? Said it was a strong shape.
Yeah, well, triangles are the strongest shape. I am actually on the steel bridge design team here at Virginia Tech. So each year we design and fabricate a 1/10 scale model steel bridge. And I think almost every single one of the bridges that made it to nationals, they were all trusses, and they all had a lot of triangles. I can probably drop a picture in the chat, but you can see how many triangles they used for that.
That sounds amazing. I think it brings up a good point that bridges, in reality, the type of bridge that's built has a lot to do with the setting and location, and also the available materials. So you were given dowels and popsicle sticks and things, and that is ideally a structural support that ideally is shaped into those triangular truss structures. I was going to show you, I have a favorite bridge. And maybe it's because this is a bridge right by the Hoover Dam. And you can see it's a beautiful arch bridge. And can anybody think about why an arch bridge would be the ideal type of bridge for this type of location?
Answer was because there's a mountain.
Yeah, absolutely. It's because of that. Well, and it's because of this canyon area. So you already have this really strong structural support at either end of the arch bridge. And so when you're looking at an arch bridge, you want that locked in structure at the end. So that's an ideal and also very aesthetically pleasing looking bridge there. This bridge was put in, it was named after I think a former governor of Arizona and also a former football player turned army person who served in Iraq and was killed by friendly fire, Pat Tillman. So anyway, the bridge goes over the canyon that is right by Hoover Dam, and it kind of it creates a much better transport route for trucks and things. This is a major route through the state, but before they had to take this very windy path across the dam. And so this bridge went in, I guess, about 10 years ago. And how it was built was also really cool. Engineers not only have to design the bridge, but they also have to imagine how are we going to build this in this location. And I don't know if you could see it in the picture I have, but there's like a steel cable going across the canyon. And a lot of this bridge was fabricated beforehand. A lot of the pieces were fabricated beforehand. And then they were like hoisted into position by along this cable in order to get the arch put in place. So a very challenging construction job, but really interesting one. So that's why that's my favorite. So we talked a little bit about the construction strategy. We talked about the design. Let's talk a little bit about the failures. Did some people was there a common area of places where your bridge failed? Was there a real challenge with like some aspect of the bridge where you had some failures?
What was the hardest part? What was the part where the bridge came apart
There
and
were
broke?
limited materials.
Limited materials. So we gave them a budget of $400 to use. And if they had everything completed on time, and if they didn't, then they got $300. And they had different pricing structures. The kids that were on time had a lower price, like Amazon Prime members, versus kids that were behind had to use a higher price with less money.
That's interesting. That kind of simulates in real life. I know that Joanna has worked on a construction site. I've also worked in construction. And a lot of the time it's balancing, making sure that everything is on time and making sure you're on time, doing things safely, and staying within the budget. And you're trying to balance those three while also staying on track with the design and also making sure that the design is structurally sound while also balancing those other aspects of engineering, at least. I know that in my career so far, it's been a lot about staying on schedule and the budget that can wait for later. And we can do some like budget cuts later on in the project, but making sure that everything is good and structurally sound in the beginning is what's important. Joanna,
Yeah,
I don't know if you have anything to add.
I do. I was just thinking that's so true, Morgan. And a lot of construction contracts are written with the idea that companies will have to pay additional money if they don't get the job finished on time, or they will lose payments if they don't get the job finished on time. So the construction schedule is critical to the success of the job. So you can imagine during the pandemic when we had some supply chain issues and it was difficult to get equipment. Those kinds of things really could throw off the schedule of a job. And so there would have to be a lot of renegotiating of contracts to make sure that the schedule could be adhered to. So yes, time is money in the construction business. But all the while, a big important consideration is safety. And that always comes, a good construction company puts safety at the top of their priorities and tries to have zero work accidents on their sites at all times. Did you see that? Did you see that in the company you worked for, Morgan?
Yeah, definitely. I worked on a 12-story demolition project
Mm.
on as one of my projects for my internship about 2 years ago. So, that was a lot of making sure that everybody, once you got to a certain height and you were like close to the edge while doing the demolition, like everybody had fall protection. I was on the contractor side rather than the crew side, rather than the engineer. I was working with the contractor, and it was very interesting. I heard all the internal discussions. I went to many safety meetings, and it was all talking about how, like, if you see somebody like doing something incorrect on the site, correct them and make sure, because that'll make sure that there's not a safety accident down the line. Since one of the workers forgot to cover up a little hole. I think it was on the eighth floor, but there was a hole like large enough that if I had stepped in it, I would have gotten my leg stuck. So just making sure like tiny things like that, that will, if OSHA, so OSHA is like the big safety people for America. If OSHA came on site, we would have gotten fined. So that's also another aspect. So making sure that everybody goes home safe at the end of the day and making sure that the job stays on track. Are
Um,
there, oh wait, Joanna, do you have anything
I
to
was just
add?
gonna ask, we've got, I think we've got about 10 or so minutes left, and 10 or 15 minutes left, and I really want to make this time valuable for you all. So I wanted to know if you had any questions regarding choosing a major or more questions about engineering. I'm going to share a slide just to see if I can inspire some to help you think of some questions, but we would love to know what questions you have for us, and help you with some questions or have a discussion.
Or even questions about bridges too. I actually took an entire class about bridges, and I learned a lot about like European bridges, and I actually got to study abroad and look at them.
We got a question. Ollie, what's your question?
You guys built a bridge.
Have you built a bridge?
Yes, I actually have. So similar to what I was saying before about the Steel Bridge design team, it's about a 20-foot bridge and it can hold 2,500 pounds and it only moves down about an inch. So last week we actually took our bridge from 2022 to the structures lab and we loaded it up with about 4,000 pounds, and that's when it finally broke. So we tried to just see when it would break and how it would break. But we do all of the welding and the cutting of the steel and the machining of it ourselves. And then we actually need to construct it on site. So similar to what Joanna was saying about the interesting build of the bridge, that's her favorite bridge. We have to come up with creative ways to construct with as quickly as possible while also balancing how many crew members we have. So it's kind of like all aspects of engineering using that construction and contractor brain while also using the structural engineering brain.
Do we have questions about like going to college or what type of classes you should take in high school for doing engineering or other science majors? What are some other things you got out of the bridge project? Something that you found interesting or something that was difficult?
I can answer the question about what you would do in high school to prepare for college. So when I was in high school, I was in a STEM program in Maryland outside of DC as well, similar to what Joanna was mentioning. And I had the opportunity to take a lot of AP classes. So I focused in on more of like the environmental aspect of things. So I actually got to clone DNA and I learned a lot about different types of engineering that I wanted to do. and what type of engineering I did not want to do. So I learned that I did not want to clone DNA as my career, which was honestly really nice to learn when I was in high school, because then I wouldn't have to spend that time in college learning and taking those classes and not doing well in those classes, or doing well in those classes and being bored at a job down the line. So I took a lot of AP classes, and then I also figured out what I did not want to do with my career.
Yeah, that kind of goes back to sort of thinking about what you enjoy doing. I can give you another example. My daughter loves to read. She had her nose in a book from the time she was teeny tiny. And she thought she would love being an English major. And she really launched into that when she went to college. But one thing she discovered with being an English major, and I don't want to knock anybody who is thinking about English, but it does involve writing a lot of papers by yourself and maybe reading a lot of works about an author and analyzing the different works of that author. And she found she really did not like writing those long papers and being sort of isolated in the work that she was doing. She thrived. She discovered when she was at college, she seemed to gravitate towards things where she could do like community work and stuff like that. And she realized that's what I actually really love doing. So it's hard. You don't have to have it all figured out in high school by any means. You've got plenty of time to figure things out, but I thought that might be helpful to know that sometimes that thing that you love doing, the training of it may not be as fun as you had imagined. The type
Yeah.
of work, the type of projects that you like to work on should be also a consideration in your thinking.
Yeah, I can also comment on that. So back in high school, I learned what I did not want to do, but going into college, I wanted to do environmental engineering, which has a lot to do with chemistry. And I went to college and I took my first chemistry class, and I did not do well in that. I did not like that class at all. And so I learned like, oh, I don't want to do environmental engineering, but I was kind of at a loss. I was like, I still want to do civil engineering. So I kind of jumped into land development. And that still has some environmental aspects. You got to think about the watershed. You have to think about making sure that there's enough open space, grass, and making sure that there's those erosion sediment control measures put in place as well. So you have to, so I'm still having a positive impact on the environment from a different SAT point of view. So I still got to do what I wanted to do, but I didn't have to take those chemistry classes to get there. Do you guys have any other questions?
So that's questions about process of engineering, being an engineer, what type of jobs you can get.
Well, I can touch on the what kind of jobs you can get. So, back when I was in high school, I actually did an internship where I researched RNA and DNA, I think. It's been a while, but I actually had that opportunity, but it was an unpaid internship. Since internships are a little bit less likely to pay high schoolers, but it still looks good, really good on a resume. But once you get to college, a lot of internships, if you make a LinkedIn profile, if you just go to career fairs, a lot of people will be like, hi, like, can I hire you? Like, as long as you can shake a hand, look somebody in the eye, and you'll be like, yeah, like, this is my name. Um, can I work? Like, this is my major. What like opportunities does your company have? That's kind of what I've seen. On my end, I know that I go to Virginia Tech, which is a top-notch engineering school. So a lot of the times companies will go there and seek out Virginia Tech engineers. And a lot of the times they'll also go to, they'll post on LinkedIn all of the colleges they'll be going to. And then they'll be like, oh my gosh, we're still looking to hire. We want a lot of engineers. And I know that at least my professors will reach out to us and be like, hey, this company is located like here tonight, like go to this like dinner with this company and maybe you'll get a job out of it. So it's a lot of listening to your professors while also being on the lookout for those career and job opportunities.
And I think I would add, don't be afraid to take a job that might not sound like it checks all the boxes of things that you'd like to do, because all experience is good experience. And I think it can tell you as much about what you like doing and as much about what you're good at as what you don't like doing. So think about that. I did not have internships in high school. And I did not have internships in college. I worked when I was in college, but I think that's really good and looks good on a resume too. Holding down a job, and showing up is a really good thing to have available or showing on your resume. So I think just be open to new experiences would be perhaps a closing message as we head into this holiday season. I hope that you are going to have a wonderful, wonderful break. I know it's only your days away, your hours away from it now. I really thank you for your good questions and your attention today. It's early in the morning there, I know, but you still showed up and asked some good questions. Thank you to Mr. McChesney as well. It's been a pleasure to be in your classroom this morning. And please reach out to Engineering Tomorrow if you have more questions. Those emails find their way to me and the other staff engineers, and I can get answers as you have them.
Thank you very much.
Thank you very much for joining us, and we look forward to working with you on another lab. Thank you, Joanna and Morgan, for your time this morning, and to the students. Thank you. Enjoy your break.
Yeah, thank you. Have a great holiday.
Bye-bye.
Thank you, Kevin.
Bye.